Okay, so we are going to do the problems on page 44 of your book as example problems today. As we go through this section, there are additional problems posted on the website on crewphysics.com. They are posted under the assignments tab. You can feel free to do those. I'll also be posting some additional sample problems that I've done with other classes. They are if you can do the WebAssign, you are good to go. Okay, just keep that in mind. But for the quiz or the tests that are coming up, but these are just additional problems to practice and give as examples. So the first problem here says Heather and Matthew walk eastward with a speed of 0.98 meters per second. It takes them 34 minutes to walk from the store. How far have they walked? So in any of these problems, the first thing you want to do is read it. The second thing you want to do is you want to get all the information jotted down onto a piece of paper with data. Get rid of the words. Get right to the numbers. So Heather and Matthew walk eastward 0.98 meters per second. That's a velocity. So I'm going to write that down. So the velocity is 0.98 meters per second east. The second term is that it happens for 34 minutes. 34 minutes is a unit of time. And then the question is, how far did they walk? So time, 34 minutes. And what is the distance? In this case, distance and displacement are going to be the same because it's one directional. So speed, velocity, since it's east, we would probably be dealing with displacement because they gave us a velocity, but the distance and the displacement will be the same. So in looking at this, I have all the information, the key information I need, because I know that velocity is equal to delta x divided by delta t. I have two of those three pieces of information. Before I go any further, I need to stop and think about this for a minute because I have meters per second and minutes. And that probably means you have to do something. So I'm going to give you a few minutes to solve for x. So at this point, you plug in your numbers. You get 0.98 is equal to x. Remember, we have to convert here. So to convert minutes to seconds, you are going to do 34 minutes times blank minutes. Put it in the denominator so it cancels out. We want seconds. Put what we want in the numerator. Put what we're getting rid of in the denominator. At that point, you would have 60 seconds per 1 minute. 34 times 60 is 2,040 seconds. So we put that up here. X then is equal to 2,040 times 98 hundredths. And we end up with 1,999.2. And this is going to be meters. Okay, so our second problem here today says Joe rides south on his bicycle in a straight line for 15 minutes and at an average speed of 12.5 kilometers per hour. How far has he ridden? Again, we're going to have to do a little conversion here. We have 15 minutes. We have kilometers per hour. So the question of how far has he ridden? So let's write down our data. Writing down our data, read our problem, write down our data, get rid of the words. So step one, we know that time We have a new problem here. We know that time is equal to 15 minutes. We know that the speed that he is traveling is 12.5 kilometers per hour. And we're looking for the distance. So we have speed, so distance and speed go together. We have minutes and we have kilometers per hour. I would convert them both into seconds, although you could convert kilometers per hour into minutes as well, but if we're going to do this, we might as well go all the way to seconds. So 15 minutes times 60 seconds per 1 minute. That gives us 900 seconds. 12.5 kilometers per hour times 1,000 meters per kilometer, and that's cancel out the kilometers. And then we have hours over seconds here. We want to cancel the hours out. The hours are in the denominator, so the hours have to be in the numerator. They have to be in the opposite spots to cancel. So there are 3,600 seconds in 1 hour. So when we do this, we get 12.5 times 1,000 divided by 3,600, and we end up with I entered that in my calculator wrong, 3.47 meters per second. Okay, so from there, let's solve for distance. I'll give you a second to solve for distance. Okay, so in terms of distance, we would have had speed is equal to distance divided by time. So that means that speed times time is distance. So the speed was 3.47. The time was 900. The units are right. Meters per second. Seconds, the units of seconds will cancel out here, and we will end up with a distance of 3,123 meters, or 3.1 kilometers if you didn't do that conversion earlier. So our next problem is you take a 9.5 minute walk with an average velocity of 1.2 meters per second to the north from the bus stop to the museum entrance. What is the displacement? So the hardest part here, again, is the conversions. So let's just knock this one down. We have we'll check that. We have a time of 9.5 minutes. We have whoa, how did that happen? Well, that's what I wanted to do before. We have a velocity of 1.2 meters per second. And so what we end up with here is a conversion, 9.5 minutes times 60 gives us 570 seconds. And so velocity is equal to displacement divided by time. So velocity times time is displacement, which means that 570 times 1.2, or 1.2 times 570, gives us a distance of 684 meters. Okay, so our next question, number 4, says Simpson drives his car with an average velocity of 48 kilometers per hour to the east. How long will it take him to drive 144 kilometers on a straight highway? So the velocity is 48 kilometers per hour east, and the displacement is 144 kilometers, and we're looking for time. Let me just double check those numbers. Yep, that's right. So to solve for this, we're going to leave everything in kilometers and hours. We're in those units. So velocity is equal to displacement divided by time. So that means to get time is equal to displacement divided by velocity. So we'll plug in those numbers and see what we get. So we plug in our numbers, and we would have 144 divided by 48. Don't forget your units in your answer, so it would be 3 hours. 3 hours. Number 5 takes a look back at number 4. How much time would Simpson have saved by increasing his average velocity to 56 kilometers per hour east? So we just changed the denominator here. 144 divided by 56 gives us 2.57 hours. So how much time did he save? Time saved would be 3 minus 2.57, which would equal 0.43 hundredths of an hour. And if we want to change it into minutes or seconds, you could do that. So this is number 5. And then number 6 says to us, a bus travels along a path south, and I think this would be closer to some of the questions we might see on an exam. The first ones just get us into speed and velocity. You might see a question or two like that, but I think you're definitely going to see something like this, where we have a bus travels 280 kilometers south along a straight path with an average velocity of 88 kilometers per hour to the south. Then the bus stops for 24 minutes. Then it travels 210 kilometers south with an average velocity of 75 kilometers an hour to the south. How long does the trip last? What's the average velocity of the trip? And so to do this, we need to get some data down. I think a picture always helps here. So we have our bus. It's traveling south. It travels 280 kilometers south, 88 kilometers per hour. We do not know the time. Now everything we're dealing with here is one-dimensional, means it's forwards and backwards, up and down, or left and right, or some one-dimensional motion. We're not going in the X and Y direction simultaneously. But I can't draw that because it would be very hard to understand what was happening in the picture if we keep drawing our up and down over that line. So what we need to do is come sideways a little bit, and we're going to stop here. So we're going to have a velocity of 0 for 24 minutes. And that is going to be a net displacement of 0. You're not going anyplace. And then the person or the bus continues to travel 210 kilometers south, 75 kilometers per hour. So we keep going 210 kilometers south, 75 kilometers per hour. Again, we don't know time. Now we have some problems here conversion-wise. We have hours and minutes. So we need to get them squared away. I don't care which way you go with this. I'm going to convert to minutes. I'm going to convert to hours because that's the least number of conversions right now. If it doesn't ask, I would choose that option. If it does ask for meters per second or something like that, you'd have to do that. But if it's just a case like this, it makes the most sense to change that 24 minutes into hours. So 24 minutes times 1 hour per 60 minutes gives us 0.44 tenths of an hour. So now we need to find, the question asks us to how long does the trip take and what's the average velocity. So time-wise, we need the time for each of the two legs that we don't have time for, the first and the last. So to find time, remember time was equal to displacement divided by velocity. So it would be 280 divided by 88. So that's 3.18 hours. And then the other time is equal to, again, x divided by v, it's equal to 210 divided by 75. So 2.8 hours. So our total time is going to be about 6.4 hours, 6.38 hours. So you add the times together, the answer to A is total time is equal to 3.18 plus 0.4 plus 2.8. Again, that's 6.38 hours. And the distance traveled and the displacement, because they're in the same direction, we didn't change directions here, is going to be 490 meters, or kilometers. And so our average speed and velocity would actually be the same here. It would be 490 divided by 6.38, or 76.8 kilometers per hour, which makes some sense. Can't be any bigger than 88 because that's your maximum speed. You wouldn't have an average between there. The 0 brings it way down. In fact, you're not moving. Averages out to bring that way down close to the 75. If you have any questions, let me know.